Okay, this is my Physics Lab 5 lab report on change in energy. The purpose of this lab is to graph and visualize the change in potential kinetic and total energy of a projectile. In the lab, I analyzed and graphed data from tracker software to measure the change in energies of a paper ball projectile being thrown. I then created code that modeled the projectile and changes of energies and graphed that data. In the end, the graphs were very similar to each other and showed that the change in total energy is zero throughout the path of the projectile. And in this lab, the system is the ball and Earth. Okay, physics principles in this lab. Physics principles used in the lab were Newton's second law and the energy principle. Newton's second law states that an object's momentum changes only when there's a net force greater than zero acting on the object. The energy principle states that the change in total energy equals the change in potential energy plus the change in kinetic energy. Okay, in this experiment, the paper ball was thrown at an angle to the horizontal, going up, reaching max height, and then going back down. Gravity is always acting downwards, meaning there's a net force acting on the ball. This was the output from Tracker. Tracker output this data of the X and Y position, and then I transferred this X and Y data into potential and kinetic energy of the paper ball and also total energy. This is the graph of the changes in potential, kinetic, and total energies associated with the graph from Tracker. The change in total energy pretty much remained at zero, while the potential energy decreased and the kinetic energy increased. So this is my code. This first bit of code initialized values like the mass, position, and velocity of the ball. The second bit of code updated the velocity and position of the ball in a loop using velocity and position update formulas. And then this last bit of code calculated the kinetic, potential, and total energy of the ball and also calculated the changes in these energies. This was the graph output by GlowScript showing that the potential energy decreased, the kinetic energy increased, and the change in total energy remained at zero for the most part. In this graph, the blue line was kinetic energy, the red line was potential energy, and the green line was the total energy. Okay, so for the comparison in graphs, both graphs showed how total energy did not change for the paper ball projectile. This is because there was no external work acting on the system. Possible sources of error that would account for slight differences in the graphs could be the minimal air resistance acting on the paper ball in the experimental model. This could cause the total energy to be different. So additional questions. What would happen if the projectile was thrown on the moon instead of the Earth? Would the change in total energy be zero still? And the change in total energy would still be zero. The potential and kinetic energies might just change at a slower rate because of the lesser force of gravity on the moon. And then second what if question, what would change in how you analyze the changes in energy if the system consisted of only the paper ball instead of the paper ball and Earth? And the total energy would change in this case because there would be no potential energy. It would be a point particle system. The total energy would increase as the kinetic energy increased.